Okay, so let's start the class. Remember, you do have 2 assignments due this week. If you need an extension, you can always email me. Rather you asking for an extension, rather just doing plagiarism, right? But don't push it too much, right? But if you need an extension, just email me. And so before we start, I just want to make something clear so you all know how to do, not to do that mistake. So let's see, you have your TI. Let's say you have a question like you have 10 to the 24 molecules of nitrogen, say. And you know from chemistry that 1 mole contains 6.022 times 10 to the 23rd molecules or atoms or whatever it is, right? Cookies, you can have 1 mole of cookies if you want, that will be a lot of cookies. And you want to know how many moles in there. So you have to divide. Do you all agree with that? To see how many moles goes into this number. But I just want to show you a mistake that you do not want to do. So if you use the trick I showed you last time, so you will say 5 times 10 to the 24 molecules, okay? How many into that goes 1 mole? So you divide by, you don't need parentheses, here you just do 6.0, just kidding, 0.22 times 10 to the 23, okay? A mistake again, 23. Is that right? Mm-hmm. And it's about 8 moles. Do you agree with me? However, if you do it a different way, so if you do it like this, 5 times 10 to the 24, and now you want to use a different scientific calculator, you want to use base 10. So you will, and you forget to put the parentheses. So you do 6.022 and you think you are doing right, and then times 10, and then raised to the 23, right? It looks right. You agree? That's the same number. That's the base 10, exponent is 23. But look what's happening. We are not getting the right answer. Why? Because of pandas. So the calculator is going to divide first by 6, and then it will multiply by 10 to the 23rd. Okay? Because Panda says you multiply or divide whatever comes first. So don't do that mistake. Because usually for multiple choices, one of the choice will take this in account as a mistake. So if you want to do it this way, it's fine, but you have to frame the denominator. Okay? Just voice of experience. That's why I'm telling you this. Also useful for chemistry. Okay, and last time we talked about the average speed. So speed has a magnitude and a unit. It's a scalar. The definition is very simple. It will be the distance covered divided by the elapsed time. You have to be careful with the units, right? So here, meter per second. That means the distance has to be in meters and the time has to be in seconds. Is that clear? So I have a video just for fun. You can make video of demonstration, but maybe not that one. I'm not sure it's that safe. But the question is, what do you think will go faster? The speed a bullet that you shoot, for example, the speed of a bullet will be larger or not compared to a breaking glass. So when you break glass, if you have a piece of glass and you break the glass, the crack is going to propagate, right? It's going to move forward. Which one will go faster, breaking glass or a bullet? Breaking glass? So let's see. So they did that very cool experiment. Do you know this one? It's interesting. because he's cracking glass just at one end, and you see it's propagating, right? It has a constant speed. You can see it's moving, okay? It takes the same time to cover the same distance. So it's a constant speed. The bullet is right there. And you see the cracking glass. It's gonna be faster. So you see it's a constant speed. Interestingly, the speed of a bullet is about the speed of sound in air. And you all know that the sound will move faster in a solid because the molecules will be packed together, they will be closer to each other, so it will be easier to pass on the disturbance. So that will be about the speed of sound in a solid, in glass, and that will be the speed of sound in air. If you divide those numbers, okay, you get a factor of 4. So that speed here is 4 times this speed. But you don't want to do that experiment, okay? Don't go and say that I did to do that, okay? I didn't say that. It doesn't look very safe. Okay, so we define physical quantities here, equations, so we did that. And then I was introducing a vector, right? So a vector, let's say you have a fly, and the fly goes, I don't know, from this exit sign over there, it's gonna fly and stop over there. The distance will be the length of the path, okay, with all the curly thing until it stops there. But what we call in physics the displacement, you will have to connect the initial position to the final position. So that will be a vector. It has a tail attached to the initial position and a head attached at the final position. Okay, so this is called a vector, and that will be the vector displacement. So, typical MCAT question, for example, if that fly starts from here, go bzzz, annoy some students over there, bzzz, and come back to the same place, what will be its displacement? 0. Not the distance, but the displacement will be 0. So a vector, okay, has a magnitude, how much? A unit of what? And a direction, which way? A scalar, like a distance, a time, energy, volume, area, they all are scalars and they have a magnitude and a unit. Okay? A displacement is a vector. A force is a vector. It has a magnitude, a unit, and a direction. So that's just to review what we did last time. And I'm not sure where we start, but we're going to be in kinematics 1D. Okay? So the physical quantities we are going to work with will be the position, x. So position, for example, when you start your stopwatch, maybe your position will be at -2. When you stop your stopwatch, maybe your position will be 3. Okay, so that will be that physical quantity. From -2 to 3, what's going to be the displacement? 5. Positive 5, right? Because you move to the right. If you start at 0 and you go to -2, what's going to be your displacement? -2. Okay, because you are moving to the left. You go from here to there. The distance is 2. So how can we find the displacement? By definition, it will be the final position minus the initial position. Okay? So if you go from -3, no, 3, just kidding. If you go from 3 to -5, what's going to be your displacement? -8. how can you find it? Using algebra, you do final minus initial. Okay? So if you go from -5 to -3, so final is, yes, it's going to be 2, you're right. If I want to use the equation, so final position is -3, so -3 minus -5, and minus 5 is just 5, minus and minus is plus, so it's going to be 2. Okay? So in kinematics 1D, it's very simple. The displacement is a vector. All you have to do is subtract final position minus initial position. Okay? We're going to talk about velocity. That will be also a vector. Okay? It will be a function of time, and we will talk about acceleration. It is also a vector, and time is a scalar. Okay? So, for example, if you are on the number line, let's say you are on the number line, okay, and your position at t equals 0 is 10, and you do have a velocity, right? So let's say you have 5 meters per second, and you are moving to the right. So that means when you start your stopwatch, okay, you are at position 10, and you move at a speed of 5 meters per second. After 3 seconds, what's going to be the distance covered? 15, but you start at 10, so that's going to be 25. Okay? So your position as a function of time will be wherever you started from, so 10, plus whatever distance you are covering. So this is called a kinematics equation. It's going to give you your position on the number line, even given your speed here or your velocity and your initial position. So what did we say? After t equals what? The 3 seconds. So I stop the stopwatch. I'm going to be at 25. I'm still moving, but that's where I stop the stopwatch. Okay? So just an introduction. Now the displacement, you could be moving up and down. Up will be positive and down will be negative. But it's the same idea. Displacement is the final minus initial. By the way, you need to start reading the textbook that I have recommended. And the unit we are doing now is Kinematics 1D. So it will be very helpful if you study along and at least go over the solved problem, because they are very good. And they try to connect with biology, chemistry, sport. It's a very nice textbook. So let's do something easy. So all these are vectors. So if you walk 5 blocks to the right and then another 5 blocks, how many blocks did you walk? 10 blocks to the right. Blocks is the unit. 10 is the magnitude. To the right is the direction. Now, if you are looking for my office, very hard to find. So you go 5 stairs up and then 5 stairs down. What's going to be your displacement? 0, right? But your distance will be 10. So muscles don't care about those stories about vectors, right? Your muscle will be tired. So same thing with forces. Forces pull and push are vectors. So if someone is pulling me 5 pounds to the right, and someone else is pulling me. You know, the student wants to ask a question, and then another student wants to ask a question. So 5 pounds to the left. So what's going to be the sum? 5 to the right and 5 to the left, 0. So that means I'm not going anywhere. Used to be in France, and in Europe you had those horrible torture. They came up with horrible tortures, and you will have someone with 4 horses, right? And the horses will pull in different direction, but all together, the sum of the vectors will be 0. So that means the body will not go anywhere, and you can imagine. So in that case here, 15 to the left and 5 to the right, that will be 10 left. It could be up and down, right? You can move, you can fall 4,000 feet down, like if you're an insect, and then 500 up, the total displacement will be down. Okay, so these are vectors. They don't add up the same way than we add numbers. Okay, so that was distance versus displacement. Speed versus velocity. Speed is a scalar. It has a magnitude and a unit. However, velocity, it's a vector. So not only it has a magnitude and a unit, but also a direction. Which way? If the velocity is positive, that means it's moving to the right. Right, that's good. And if it's moving to the left, the velocity is going to be negative. Okay? So, but here the speed is the same. Velocity is not the same because you have a minus. Minus means to the left, except instead of saying at left or at west, we say we show the direction with a negative sign. Okay? So let's do this one. I'm missing the definition of velocity. I don't know. I'm missing a slide. I'm going to add that. So the definition is that, okay, velocity here is a vector. So that's why I have a little arrow here on the top. And I'm going to put here a bar to say it's the average. So the average velocity, it's going to be, by definition, the displacement, which is a vector over the time elapsed. So that's a definition for velocity. The speed, okay, so the definition for speed is the total distance over the total time elapsed. So this is a scalar, and this is a vector. V for vector, S for scalar. This is displacement. Usually the unit here is meter per second, and here it's meter, and here it's second. Now displacement is a vector, but on the number line, what you do is the final position minus the initial position. Okay? So that's the definition. I'm missing the slide. I don't know where it went, on vacation somewhere. So average velocity is displacement over time. Okay? And that will be average speed. So in that case, you start your stopwatch here, and you stop your stopwatch. This is the initial position. This is the final position. So you connect them. Okay, tail goes to initial, head goes to final. So that's going to be your displacement. And this is the time elapsed. Can you find the velocity here, in this case, and the velocity there? So you can always help each other. If you need a TI, have one. But otherwise, So you can talk to each other and you don't stare at the screen, because if you stare at the screen, nothing will pop up. You have to do it. And time will run faster if you try to do it, because time is relative. Einstein said so. So it has to be true. So velocity for the first run is going to be displacement. It's a vector over time elapsed. Okay, displacement, you see it's a positive here because it's moving, it's to the right. Okay, so do it on your own. Everything is in my PDF. You have access to my PDF, so it's easy to upload the PDF on your tablet. Time elapsed is 4.74. So what do you get? 339.5. Right? 339.5, right? Mm-hmm. 4.5, and I round meter per second. Is that right? Yeah. If you do the significant figure thing, you say 1, 2, 3, 4, okay, 1, 2, 3, 4, okay, 1, 2, 3, 4, okay. What about the second hand round? It's going to be negative. Do you all agree with that? Yeah. So the displacement here, it's pointing to the left. So it's going to be the same distance, but not the same displacement. And the time is a little bit less. And you get exactly meter per second. Okay, so average velocity, that will be the definition. And there is a negative here, that will be the direction. How much of what, which way? Okay? So this slide actually comes from the textbook I recommended, right? The one from Johnson and Cocknell. That comes from that book. That's why it's easier if you take this book. So we can try. Let's see. Okay, let's try number 4. So all this here, this problem, you have a tutorial in the Dropbox, okay? All the problems in my slides, they have tutorials. But you can help each other and try to do this one. You have to be careful with the units, right? You want to make sure that you get the right units. So you want the unit in blocks per hour. So first of all, I'm going to say north here, this is south, this is plus here, and this is minus. Okay, I'm going to define displacement here, delta y, because it's up and down. So the total displacement is going to be what? You go 5 up and 10 down. It's going to be negative 5. Do you all agree? Mm-hmm. So you can say negative 5 blocks, or you can say 5 blocks at south. How much of what, which way? Now, if you want to understand, you start from point A. And then you go up by 5. Okay, you go up by 5. And then you change your mind and you go down by 10. So what matters is always initial position, and then your final position is here. To find the vector, you connect initial to final. Okay, so this here we call that the tail of the vector, and this is the head of the vector. The magnitude is 5, but the direction is negative. Is that clear? Now, a vector can be copy and paste. So that means I can make that vector here, I can make it here, I can make it here. It will still be the same vector, 5 blocks down. Okay? Now, what do you think here? Let's say I ask you for the pop quiz. You go this way, you are really changing your mind all the time. You go here and there and there, and then you go here, and then you go there. So how are you going to draw the vector? From point A to point B. Exactly, from point A to point B. So that will be your vector displacement. We can call that, for example, I don't know. Oh, I know how we're going to call it. We're going to call it AB. Okay, it's a vector. It goes from A to B. Okay? So if in your textbook or if you have introduction to physics, you know, they always talk about vectors. So let's go back to our business here. What is the average velocity? So it's going to be negative 10 blocks per hour. Very good. So velocity here, average. I use a definition. It's going to be displacement over time by definition. So it's going to be minus 5 blocks. The time is 30 minutes, so that will be half an hour. Okay, so I'm going to put a 0.5. When you divide by 0.5, it's like multiply by 2. So that's going to be negative 10 blocks per hour. That really doesn't make sense in that situation, but that's the definition. So if the fly goes from that exit sign and go back, what will be its average velocity? 0. Not the speed, but in physics, if you stick to the definition, it will be 0. Now, the average speed, it's going to be, what's the distance, the total distance covered? 15 blocks. So 15 blocks, you're right. So 15 blocks. And the time elapsed is 0.5 hours. So that will make sense in the real life, right? So that will be 15 blocks per hour. So that's a scalar. It's a real life thing. And it has a magnitude and a unit. So it's not intuitive because velocity and speed in physics are not the same object. They are not the same physical quantities. Yes? Sorry, wouldn't it be 30 blocks per hour? You're right. I was checking if you were paying attention. Thank you. Okay? Do you all agree? Mm-hmm. Okay. Let's do, I don't know, number 7. So this really does not have sense in the real life, but it's just to teach you how to stick to definition. So you go 5 up and 15, 15 up. No, you go 5 up, 3 down, and 15 up. So that's going to be 17. Do you all agree with that? Yeah. So the displacement Okay, it's gonna be 17 inches at up or plus up. So the velocity, the average velocity by definition, it's going to be the displacement over the time elapsed. So it's going to be 17 divided by 2. Is that right?
Yeah.
So is that 8.5?
Yeah.
Inches per second, and it's plus. But the average speed is going to be the distance over the time. So it's going to be, yes, 23 over 2. Is that right?
Yeah.
So 11.5, thank you, inch per second, right? Okay. Don't hesitate to tell me your name or before or after so I can remember. And then it says 2.1. Okay, so that comes from a book. So it's not the book that I have recommended, but it's okay. It's a book that the department has recommended.
Oh, I need something more.
Okay, another thing that doesn't make sense in the real life. Okay. Try this one. Can you see? Is that big enough?
Mm-hmm.
She'll start from A. She goes to B. So that's going to be the displacement here. Okay. A, B is plus 50 meters. Now, if you take the number line, X, that will be your initial position there. So then we can say delta X equals, and the time elapsed is 24 seconds. So the average velocity, it's going to be on the way 50, right, divided by 24. Watch the units. So it's going to be about
2.08.
very good, meter per second. Okay? For each length. So on the way back, she goes from A to B. So what's going to be the displacement? Very good, negative, right? So it has to be negative over, but she's tired. I don't know her. So I guess, yes, she is tired. So it's going to be negative. Yes, 48. So it will be negative. Very good. Meter per second. However, tricky question. If they ask you the average velocity for the entire trip, so she goes from here to there and then back, the velocity will be 0. not the average speed, but the average velocity. Okay? So I've seen one like MCAT question. They say, okay, you do 2 kilometer east and then 2 kilometer south and then 2 kilometer west and then 2 kilometer north. What's going to be your displacement? Okay, but what's the distance? 8, right? Okay. Okay, let's do something a little bit more challenging, not that much. You see here, what you see here, it's the position. So what you take your number line, let's say you have a number line like this, and you make it like that. So if you want to understand graphs, and if you're in biology, biomedical, you always have to make graphs and understand graphs. So here you have the time. What does that mean? It means it goes from 0, move toward the positive here, goes to position 20 here, and then what's happening? It's going back to 0. Do you see how it works? Right, so it's like you're moving on the number line. You go from position 0 to 20, you change your mind, and you go back to position 0, except here you have the time. So what's the displacement? You go from 0 to 20 back to 0. What's going to be the displacement? 0. So the average velocity will be 0. However, let's find the average speed. So what's going to be the distance? You go from 40, very good. You go from 0 to 20 back to 0. So it will be 40. What will be the time elapsed? 20. So the average speed will be, very good, 2 meters per second. Okay? Okay, so now I want to talk about relative velocity without any equations, just with the guts, right? Common sense. So relative velocities were introduced by Galileo and he published this book here, very famous book. And I don't have the name of the book, but let me find the name of the book. Yeah. It's called The Two Chief World Systems. It was like a revolution at the time. It was the first one that someone was discussing relative velocity. Okay, he didn't get in trouble for this book. He got in trouble for the next book. The next book said that the Earth was not at the center of the solar system. He got in trouble, but he had connections. Connections. So he was not burned at stake. That will be very unpleasant. So let's see if it makes sense to you. If I'm sitting there, I see that the velocity of this car is plus or minus. Let's say it's moving to the right. Plus. And this one is minus, right? But if you are sitting inside this car, right? So your frame of reference is inside the car. It will take less time for the crash to happen, right? Because you move closer to each other. So from your frame of reference, what's going to be the relative speed? You get close to each other very quickly, right? So the relative speed relative to you, in your frame of reference, you are not moving. You are driving, but you are not moving relative to the car. That will be very weird, right? You cannot start driving off the car. So you are at rest inside of the car. Relative to you, this car is moving at a speed of 60, right? What's your name? Matthias. Right, 60. Does that make sense? Because look, if you are not moving, the car is moving at 35. But if you are moving, you're gonna take less time to meet, right? So relative to you, the relative speed is 60. Does it make sense?
Yeah.
Now, if you're moving, so it's going to be negative 60 because it's moving towards you. If it's moving away from you, it will be positive. Now, let's think about it here. From someone outside, this car has 60, a velocity of 60. This one has a velocity of 55. Now, this one is moving toward the other car, right? So it's going to take more time to catch up because this one is like fleeing away. So maybe this is a police officer. This one had a speeding ticket and tried to escape, right? So the velocity between them, 5, very good. 5. You don't add up. You add them up when you are moving towards each other. When you are moving in the same direction, you subtract. Does that make sense? Now, from my perspective, if I am sitting in there, the car in front of me is still getting closer to me. I'm going to catch up on him. So the relative speed will be negative 5, right? So it's like when you are driving, okay, and a car in front of you is stopping because there is a red light. From your perspective, that car in front of you is getting closer to you, right? Does it make sense?
Yeah.
So that's how it works. So typical question here, easy questions. You have an airplane, okay? The speed of the engine says 100 kilometers per hour, but that will be the speed relative to the air. So how does an airplane work? It's pushing the air back. So the air is pushing it forward. So relative to the air, the speed is 100 kilometers per hour. But at the same time, you have a headwind, right? Opposing the airplane. So relative to the ground, the velocity of the airplane will be what? 80. Okay? Of course, the wind is going to slow you down. Does that make sense?
Yeah.
Okay? So it depends on your frame of reference. In your frame of reference, you're going at 100 kilometers per hour. Someone looking at you on the ground sees that there is a wind, a headwind, so you're not going to go as fast. Is that clear?
Mm-hmm.
So this is about relative velocity, and it depends on the frame of reference. If you have a tailwind, so you still have an engine working at 100 kilometers per hour, but now the wind is pushing you. What's going to be your speed relative to the ground?
120.
120. Okay? It gets more complicated in 2D, but for now we are in 1D. So I have found this very good example because when I teach this, sometimes it's confusing. But look at this one. If you have enough room in your apartment or house, rather, so if you are moving at 2 miles per hour to the right, okay, and the water is flowing 2 miles per hour to the left, what's going to be your velocity relative to someone sitting outside? 0. It seems that you are not moving. Example of a demonstration. If you go to the airport, I don't know, to pick up someone, and you have 5 minutes to kill, you go on the running sidewalk, right? So the sidewalk is running this way. Try to match the speed, but the opposite direction. For the camera or someone sitting outside, it seems that you're not moving, right? So you can add up, like if you are in a hurry about to miss the plane, the speed will add up. But if you move in opposite direction, it will subtract. Does it make sense? So there is another demonstration that you do not want to do because it looks very dangerous to me. But it depends on your frame of reference. So let's see if I can find this. So you have a car. And the car has a platform here. And let's say the car is going at 5 miles per hour. So if you are here and someone looks at you here in that frame of reference here, what's going to be your speed? 5 miles per hour, right? If you jump, that will be very bad because you keep your 5 miles per hour, you're going to be pushed in this direction and you're going to fall. However, if you start to run at exactly 5 miles per hour, what's going to be the speed relative to here? 0. And if you jump, you'll be fine because you have no speed. It's going to be 0. You're not going to fall back or forward. You're just going to stay there relative to the ground. So he did this experiment, and you cannot do it. It takes too much stuff. And it doesn't sound very safe.
Hey everyone, today we're going to be seeing what on and I jump.
So here he has this same
Okay, so
speed.
why didn't I fly off the trailer when I jumped up when we were driving at a constant velocity there? Well,
you see, relative to the platform, okay, he's at rest, right? So if he jumps, he will go back to the same place. Relative to the ground, he's moving at 5 miles per hour, okay? But look what he did. You need a very cooperative wife in this case. It's very hard to achieve.
woo!
So he's moving at the same velocity as the car, but opposite direction. No.
Overall, that worked way better than I thought it was going to be. I thought for sure I was going to fall. That should tell you how much I like doing this channel because I filmed it knowing I was probably going to fall, but in the end I didn't. So that's wins overall. But what does it say about my wife? She was willing to let me do it. Well, it depends on. But I had a helmet. Okay, so it actually worked. I was able to run.
So you can watch the whole video. It's on YouTube if you want. But he explained for that to work, you need to have a long enough platform, okay, to go from 0 to 5, for example, right? And then it's gonna show you that velocities are vectors, and vectors can cancel each other. They can kill each other out. So that means if you have 5 here to the left, and you have 5 to the right, when you add those vectors, you're going to get 0. So you can add vectors, and that will be a negative. Yes, no? You are just stretching. It's good to stretch. Okay? So easy demo if you go to the airport. So here are other examples. Someone is walking on a dock, and the speed is 2 miles per hour. And this is not the dock. What is that? It's a barge, and it's moving at 3 miles per hour. So relative to the barge, he's moving at a speed of 2 miles per hour. But relative to the dock, what's going to be his relative? 5. Okay? So you have an equation for that. You can see that, right? Man relative to dock is man relative to barge plus dock relative to barge. You can see it crosses out. No, here there's a mistake. It should be both relative to dock. What about here? Relative to the ground, it's going to be 1 because it's moving away. If it was the opposite, okay, so if this was 2 and this was 3, it will be -1. Very good. Okay? About average, so if a speed increases at a constant rate, so if you have a speed here as a function of time, and your speed increases at a constant rate. So that will be the definition of a linear equation. That makes sense that the average will be just the midpoint, right? That will be your average. You don't need to take physics or math. It just makes sense. That will be your initial velocity. That will be your final velocity. So the average will be the midpoint. Does it make sense? Okay? So in that case, he starts to run. I guess it's football. Is it football? Mm-hmm. Okay. Football doesn't make sense to me, but I'm sure it does to you. So he's running and he's spinning up. So he has an acceleration. But there is so much you can accelerate, right? At some point, you're going to reach your maximum speed. Okay, it has so much muscles to deal with. So you see the speed is going to increase, but it's going to increase, but at a slower rate. It's not increases as much as at the beginning. And at some point, it's going to get to an asymptote, a limit, right? So you see the average will not be the midpoint. It will be somewhere closer to the top, right? Because it takes more time trying to reach that limit than just accelerating. Does it make sense? So that takes me to the new physical quantity, which is called acceleration. And these are real life numbers. So acceleration, the average acceleration, average will be the change in speed. So actually it should be a vector. So it should be the change in velocity over the change in time. So he goes from 0 to 31.5 feet per second in 1.2 seconds, which is very good. I cannot do that, but that will give you the average acceleration. Okay, so every second is going 26.25 feet per second faster. Okay, so just to give you an idea of what an acceleration is, that means you are moving faster. So before we get to that, I just want to give you let's talk about gravity again. If I drop my notebook, is it going to move at a constant speed or is it going to speed up? Speed up. So that means there is an acceleration. The acceleration is 22 miles per hour per second. 22 miles per hour per second. So it means that every second falling, it increases its speed by 22 miles per hour. Example, if we go to the first floor, the first floor, and you fall for 1 second, what's going to be the speed when you hit the ground? 22 miles per hour, right? Every second, you increase by 22. You start from rest, so you start from 0. After 1 second falling, you hit the ground with a speed of 22 miles per hour. Does it make sense? You go to the second floor, 2 seconds, You fall for 2 seconds. How fast you're going to 44. So 22 miles per hour, maybe you're going to break some bones, but it won't be so bad. It's like having an accident of a bike. 44 miles per hour, crashing in a car, not so good, but you might survive. After 3 seconds falling, what's going to be your speed? 66. That's bad. I'm not talking even about 4 seconds. That will be what? 88, right? So just to give you an understanding of what is acceleration, how fast it's getting faster. Now, if there is an acceleration, remember there is a force. So what is the force in that case? Gravity. Where is gravity? Down. So it means acceleration is down. So acceleration is a vector, and it just means the force, right? Acceleration will always have the same direction as the force. So let's take an example here. So displacement, check that. Initial position, final position. The displacement will be this vector here. It will be positive. What about velocity? So we say positive is to the right, negative is to the left. So what's going to be is the velocity positive or negative? Positive. The force, the thrust. So you're pushing the floor is pushing you back. So the thrust is to the right or to the left? To the right. So the acceleration is also to the right. What's happening here? Is it speeding up, slowing down? Slowing down. Displacement, initial position, final position. You connect those 2 points. Tell here, head, is the velocity positive or negative? Positive, it's moving to the right. But where is the force? To the left, very good, it's friction. Okay, if you don't push the skateboard, it will eventually stop because of friction is opposing the motion. So acceleration is to the left. So acceleration in that case will be what? Positive or negative? Negative. All you have to remember is that acceleration has the same direction as the force. Let's look at this one here. Speeding up or slowing down? Speeding, right? Because every second it's going to cover more and more distance. But is it moving to the left or to the right? To the left. So the velocity is negative. And the acceleration is negative because, the first pushing this stick guy or girl, I don't know. So here you are moving to the left or to the right? Left. So velocity is negative, okay? But you are slowing down, so the acceleration is very good, positive, right? It's slowing you down. So this we'll save that for another time. Here, the idea is that it's moving at a constant speed, but the bee needs to have a force pushing it inward to keep on track. So even though you are moving at a constant speed, you need a force to push you in. So there is an acceleration, but it's not an acceleration that makes you go faster or slower. It's an acceleration that changes direction. Example, those crazy people in Miami, they are very bad drivers. So they go always, you have accidents, right? So when they make a turn, they go too fast. And if they go really fast, what's going to happen to them? They go off tangent. Why is that? Because there is not enough friction between the tires and the road, not enough force to push the car in the turn to keep the car, on track. Off track you go, right? So this B needs a force to keep it on the track. Otherwise, off tangent it goes. You know that if you are doing track, for example, at the gym, when it's going around, when you are making a turn, you have to push, right? With the outside leg, push you in. You need a force, otherwise off tangent you go. So I emphasize conceptual questions, especially with the exams in mind. Okay. So definition of acceleration. I don't know, my slide is gone again. Acceleration, the average acceleration okay, so acceleration is a vector because it has a direction. Average will be, by definition, okay, the change in velocity over the time elapsed. Delta, it means a change. So each time you have a delta, it means final minus initial. So the acceleration, average acceleration, is the final velocity minus the initial velocity over the time elapsed. So you see, it's a rate. How fast you are getting faster. Okay? So if I say acceleration is 22 miles per hour per second, so that means every second your speed increases by 22 miles per hour. Okay? So that will be the definition of acceleration. So if you go back to the I don't know, I had like a slide here. Time, check. Average speed, check. Distance, check. Position, check. Displacement, check. Average velocity here. And what's the definition for average velocity here? So it will be, so that will be the average velocity. So delta x over delta t. Okay, average acceleration is delta v over delta t. Initial velocity, check. Final velocity, check. Acceleration. Any question? So not everyone has the same background. So if you are too shy to ask questions, I'm available after the class. There is no stupid questions, and everyone has different skills. If you have me in an organic chemistry class, I will be totally lost. I failed it like 3 times. It was a disaster. It never made sense to me, okay? Never understood orgo. Okay, so this comes from and of course, do not hesitate. You need to have a study group, help each other, talk to each other, collaborative learning, read your textbook. So anyway, so you have an airplane. When you start your stopwatch, the initial velocity is 0. And then when you stop the stopwatch here, 30 seconds later, the final velocity is 250 kilometers per hour. To the right. Can you find the acceleration? Okay, so acceleration by definition is going to be final velocity minus initial velocity over the time elapsed. It's in 1D. So it's going to be easy, right? So average velocity equals final velocity. It's going to be 250. Okay, I have to pay attention to the units, but for now, kilometer per hour per second. So, what did you say? So what do you get?
8.33.
Yes, 8.333 kilometer. 8.33 kilometer per hour per second. What does it mean? It means at t equals 0, the airplane is not moving. After 1 second, what's going to be the speed? 8, right? Exactly, 8 kilometer per hour. After 2 seconds, it's going to be exactly 16. After 3 seconds, it's going to be 24, and so forth, and so on, right? That's the meaning. So it means the change of speed every second is about 8 kilometers per hour. So they have great slides. You see, when you start your stopwatch, the airplane was at rest. There's a force to the right. So the acceleration is to the right. It's going to move faster by 8 kilometers per hour after 1 second, 16 kilometers per hour after 2 seconds, 24 kilometers per hour after 3 seconds, and so forth and so on. Okay? Okay, let's think about this question here. So you have the same airplane and the same acceleration. But now you start your stopwatch when the airplane is going at 5 kilometers per hour. What's going to be the speed? So it has the same acceleration, but when you start your stopwatch, okay, you have a stopwatch, you start, the airplane was going at 50. So you can discuss that, you can help each other for the same acceleration, right? So there is a, 0 here, but when you start your stopwatch, maybe here, it was going already at 50 kilometers per hour. Now, the acceleration is, say, 8 kilometers per hour per second. I can put the 0 here if you want. That means at t equals 0, it's there. How fast it's going after 3 seconds, 5 seconds. Yes, 90. Do you all agree with that? Because every second is increasing by 8. So after 5 seconds, it has increased by 40. But then it had already 50 to begin with. So the final here will be 90. Now, if you do not understand, think money. If you're making $8 an hour, if you work for 5 hours, how are you going to make it? 40. But imagine your boss is so nice that just to show up, that boss gives you $50, right? You show up, it's $50 to begin with. Plus, you work for 5 hours, so 5 times 8 is 40. So you're going to make $90, right? maybe you have to go, I don't know, you have to commute all the way to Key West, so that's why they give you $50, right, for the gas and the car. So that's what you start with. Is that clear? So thinking of money, can you come up with an equation? So the final velocity, so the final income will be what you start with, right? So it will be 50 plus, what's the rate? $8 times the number of hours. Okay, this is called a kinematics equation. Okay. Likewise, if you are moving, like here you are moving on the number line, and your speed is slow, like maybe 2 miles per hour. 2 miles per hour, is it fast or slow? Slow? Okay, so you are very slow. So that will be your speed here. And when you start your stopwatch, here you are there. So what's going to be your position as a function of time? So that will be your time here. It's going to be 2 times time, right? 2 times the time. Okay, so that means it's hour, right? So after 1 hour, what's going to be your position? 2 miles away from your initial position. Maybe it's your house. After 2 hours, what's going to be your position? 4 miles, and so forth and so on. But now, what if you started, I don't know, 3 miles away from your house? So your position will be 3 plus. Very good, excellent, very good, right? That's another function of time, okay? And that will be also a kinematics equation. That will give you the position as a function of time. That will give you the velocity as a function of time, if you have an acceleration, of course. If you do not have an acceleration, then your speed will stay the same. Is that clear? Think of money, right? You make $2 an hour 100 years ago, but your boss gives you $3 to begin with. So that's the idea. That's also a linear relationship. So that's called the y-intercept, and that will be the slope. Okay, y-intercept and slope. So just an introduction. Okay, something tricky here. Kind of the tricky question you have when you have to take a test, MCAT or graduate school or whatever. They want to make sure that you understand that velocity is a vector. It can be positive if it's moving to the right, or negative if it's moving to the left. And they want you to stick to the definition. That means the definition of acceleration. Okay, so it's a ball and it's bouncing off. The magnitude is 5. The magnitude is 5, but now the velocity is what? Plus 5 or negative 5? Negative 5, and here it's plus 5. So first of all, I have to decide right is plus, minus is left. They want you to find the acceleration, which is, by definition, the final velocity, which is a vector, minus the initial velocity over the time elapsed, right? So we have to be very careful with the direction. So final velocity is what? +5 or -5? Yes, you're right. -5. -5, you're right. And the initial velocity is 5. And the time elapsed is 0.01. And then you need to stick to the definition. So you plug in numbers. So the acceleration, -1000. What's your name? Ryan? You're right. Did you find 1000? So final is -5 minus, you see you're bringing it down. Initial is 5. The time elapsed is 0.01. Minus 10 divided by 0.01. Be careful with the units, but here we are good. Here it's meter per second, and here we have second. So the acceleration is -1000 meter per second per second. Gravity is -10, so it's 100 times more. What kills you is not gravity, is the impact. It's the acceleration. So blame it on the acceleration. When you fall, God forbid, you hit the ground, your velocity will change abruptly in a very short time from a high speed to 0. That's going to kill you because acceleration is like a force. If you have a huge acceleration, that means there is a huge force pushing you. Not that I want that to happen. Except if you have a cat. You know, if you take a cat and it will find its way and it will flip itself, right? Theoretically, so don't try. Okay, so again, this slide comes from the book, Johnson and Cutnell. And you see here, it's slowing down, but it's moving to the right. So the initial velocity, the final velocity, they are both positive. But it's slowing down because those cars here, they are moving so fast that to slow them down, you need a parachute. Otherwise, there is so much friction that it will destroy the braking system. So it will get too hot. So they need a parachute. So the acceleration is to the left. Do you agree? Mm-hmm. Because of air resistance here and some friction there, it will be the same direction as the force. Okay? So just apply the definition. Acceleration is final minus initial divided by the time elapsed. And you get, yes, -5. Do you all agree with that? Right? Okay? If you have any question after, even if you don't be shy. Okay, so -5 meter per second per second. So it means you start with 28. After 1 second, what's going to be your speed? Positive 23, right? Another second, it's going to be positive 18. Very good. Another second, it's going to be 13. Okay, you remove 5 each time. Make sense? So here you see that here, right? T equals 0 is 28. After 1 second, it's going to be 23. Another second is going to be 18. Another second is going to be 13, and so forth, and so on. Yes?
Meters per second is the same as meters per second squared.
Yeah, so the notation, it's a good question because you have 3 notation actually. You can say 3 meters per second. So every second you change by 5 meters per second. Okay, that will make sense. But the notation will be 5 meters per second square. Okay, because it's like when you divide. So let's say you have 5 meters per second. So when you divide, you multiply by the reciprocal, right? So for example, if you have 3 over 2 over 5, it's going to be the same as 3 over 2 times the reciprocal. So when you divide by a fraction,
3 over 2 times 5 over 1.
No, you multiply by the reciprocal. So that's going to be 3 over 10. So likewise, here, you're going to do 5 meters per second times 1 over second. So that's why it's 5 meters per second square. So when you divide fraction, so 3 over something like that, 5 over 4, you multiply by reciprocal. So you have to flip this. Right? So if you have something like this, it's like you have over 1, so it will be 3 over 2 times 1 over 5. Right? Yes? So A over B divided C over D is going to be the same as A over B times D over C. So that's why that will be the same as 5 meters per second square. Is that right? Is that clear? Just notation. And just to confuse even more the student, we like to write it as 5 meters with a minus 2. Because to the minus 2 means 1 over s squared. It means the same thing. Copy me? Okay. So like a over b squared, it's going to be the same thing as a times b to the minus 2. Right? Just algebra. That's called misplaced base. So if the base is misplaced, you change the sign. So all that, it's the same thing.
Which one would you prefer us to use?
It's up to you because it's multiple choices.
Okay.
But it's a good question because sometimes in the question you're going to see this. That means 5 meters per second per second. Okay? So for example, if you do chemistry, sometimes you talk about fluid pressure. Pressure will be pounds per square inches, which is pound per inches square. So you can write it this way. Is that clear? That's just algebra. So you see, it's not the physics. Don't blame the physics. Blame the math. Okay, so what do you think? Which one is right? C. Very good, right? A means a constant speed. Every second, it's going 2 meters. That doesn't tell us anything. If the rate is constant, that means the speed is increasing by 2 meters per second every second. So 2 meters per second per second. Oh, what about here? So t equals 0 is going to be here, t equals 1, t equals 2. Is the position constant? No, right? It's moving. Is there an acceleration? No. So it doesn't decrease or it doesn't increase, so it has to be V. Right? The velocity is constant. Why? Because the speed is constant and the direction is constant. Velocity has a speed. It's a speed with a direction. Okay, little bit thinking. So acceleration goes with the force, right? Okay. What did you say? C. Do you all agree? Right? A. There is a constant speed. So is there an acceleration? No, doesn't work. You go south, so velocity is negative, and you also speed up. So acceleration is also negative. Okay. Now you go south, so velocity is negative, but now you are slowing down. So the acceleration will be in the opposite direction. One way you can remember, if velocity and acceleration have opposite direction, that means you are slowing down. If they have the same direction, you are speeding up. Because acceleration means a force, so you are being pushed forward. Okay? You are not spacing out? You with me? What about this one? So velocity is east, but she's slowing down. So the acceleration will be west. So typical conceptual question, or easy. A. Do you all agree? So when it says from rest, you translate that as initial velocity is 0. So final velocity is 25. So 25 minus 0 is 25. And then you divide by the time elapsed, which is 10. 25 divided by 10 is 2.5. Okay? Make sure, okay, if it's a little bit hard, even if it's not hard, make sure to read and study from the textbook. Which one is not a vector quantity? Huh? B is a vector quantity because it's a displacement. E as a ego. Okay. Average speed is a scalar. Speed is a scalar. So speed is a scalar. Distance is a scalar. Time is a scalar. Energy is a scalar. Volume is a scalar. Acceleration is a vector. Velocity is a vector. Force is a vector. Displacement is a vector. Momentum is a vector. Angular momentum is a vector. So what is the definition of average acceleration? D. Do you all agree? Right? So change means final minus initial. So that will be the definition for acceleration. Okay. So all those problems here, it's in the Dropbox. It's in the tutorial. Let's do. Oh, no, number 6. So this one is easy, right? So you increase your speed by 4.2 meter per second. So every second, you go faster by 4.2. So after 5 seconds, what's going to be your speed? Very good, right? You multiply by 5. I'm an old lady, you have to speak out. And then it's good, to take the stress out. You don't hesitate. Let it go, right? 4.2 times 4. Okay? So if you go from 1240 to 1300, what's going to be the acceleration? What you do, you add or subtract? Subtract, final minus initial, divide by the time. So if you need more practice, that's going to be in Dropbox. By the way, when is the pop quiz? Now, okay. If you have any question, I'm here. And make sure to go over the textbook. Plus, you have free textbook online. So